Personal finance practice problem using Excel. Monthly loan payment calculation and amortization table. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're down here in the practice tab as opposed to the example tab. The example tab in essence being an answer key. Information on the left-hand side, going to populate that into the blue area on the right-hand side, looking at a loan scenario once again similar to a prior presentation, but this time we're looking at monthly payments as opposed to yearly payments, making it a little bit more complex to do our calculations. So we're going to say that we're going to be borrowing the $11,000 for the borrowing. The interest rate this time is going to be 12%, and we're going to say that we repaid in monthly payments for 3 years. So in other words, we're going to be paying it back for 3 years, but we're going to be paying it monthly, as is often the case for many kind of loan situations like a mortgage or a loan for financing a car or something like that, as it is typically going to be set up. Now note, as we look at this payment calculation, if you were to get a loan for financing the car and whatnot, normally the person that's calculating the loan will just give you the payment information. You would like to be able to calculate it yourself so that you can go into a situation and practice different kind of payments and interest rate settings to see what would happen, and also get a better determination through the creation of an amortization table of the payments and interest and what the relationship will be to the loan. So let's calculate this out. We got our information. We're going to calculate the payment then. Now, first, you might be most familiar with that present value calculation as opposed to the payment formula. There is a payment function, in other words, in Excel. But when you're first looking at this, you might say, look, this looks like a present value of an annuity kind of thing because the payments are all the same. Let's try with the present value, see what the unknown is, and possibly use our goal seek to figure it out, and then see, using the present value function, whether or not there's another function that we could then use called the payment function to then rework the equation and solve using that function. So in other words, we might first start off and say, I know this is a present value kind of thing, so let's go present value, shift 9, and say that we have a rate. The rate is going to be the 12%. Now note, this is where it's confusing. That 12% is a yearly rate, and normally when you're talking to people, they will quote a yearly rate because the yearly rate will be somewhere between 1 and 100% generally. But we're going to be paying this monthly, and therefore we got to have the rate that's going to be equal to the payment. So I need to take the yearly rate and divide it by 12 in this case. So that's going to be the kind of twist involved here. Note that no one really quotes the monthly rate, which in this case would just be 1% per month, because although 1% is fairly easy to say, if it was 1.05432 or whatever, something like that, then obviously that becomes much more difficult to be dealing with than the yearly rate, which would be just simply 12. So years are the convention, and then you have to basically make the adjustment to whatever you need to adjust it to using your calculations. Then I'm going to say comma. We have the number of periods. Now the periods were given in years once again. It's going to be paid off in 3 years, but just like if you had a 30-year mortgage or something like that, but you know you're going to be paying it off monthly, so you're going to take that 3 years and times 12 because there's 12 months in a year. So we'll take the 3 years times 12, and then we're going to say comma, and the payment amount, that's what we don't know. That's what we don't know. So I can do two things. I could say, well, I think the end result here should actually be the $11,000, the amount we're borrowing. That's the present value. I can then use goal seek to figure out the payment, or I can go to another function and see if Excel has a function called equals PMT, which it does, which is the payment function. So we're going to start off here pointing to this cell and try to use goal seek to back into this first, because we might first understand the present value calculation best. And so there we have it. And then we can guess at a number. I could say, well, what if this was 500? We'd get a result of 1545. We want a result of 11,000. That's what should be in the end result. I would like it to be a positive number, however. So what I'm going to do is double click on this 11,000. I'm going to put a negative in front of the P, which will basically take the entire thing, multiply it times -1, flipping the sign to that 15,054 positive. Then I can adjust this number down here to like 400 and so on until I get it to what it should be at, which is that 11,000. We can then ask goal seek to do that for us by going to the data tab up top, going to the forecast group, the what if analysis, and say goal seek we're going to seek the goal, and we want to set then this cell to be 11,000, hard coding that in other words, typing it in there. And then we want to do that by changing this cell. So we're asking Excel to make that cell whatever it needs to be, the payment, so that that cell up top gets to the answer we know it should be, which is 11,000. There we have it. We're at the 365 about. There might be pennies, but we're going to keep it there. Let's look at the pennies. Are there going to be pennies? There are pennies. So it could go on here, but we're going to round it to 2 pennies, which is going to be 365.36 to get the pennies. Home tab, number group, adding the decimals. Okay, so then we could do it the other way with the payment formula, because we saw that there's a payment thing here. So let's see if Excel has a function for the payment thing. We're going to say, I think they do. I'm pretty sure. I've seen one before. I'm pretty sure I've seen that before somewhere. So there's the payment. There it is. Let's go Shift 9. We're going to pick the rate. The rate's 12%. Once again, that's a yearly rate. So we got to divide that by 12 to get the monthly rate. Comma, then we got the number of periods, which is 3, but those are years, and we're doing this monthly, so I'm going to take the 3 times 12 to get the monthly periods, comma, and then the present value is the amount we're borrowing at the current level, the current point, 11,000 in B1, and enter. There we have it once again. Let's add some decimals, home tab, number group, couple decimals, and then let's make it a positive number by double-clicking on it. I'm just going to put a negative before the P, flipping the sign of the whole thing. There we have it. So there we go. So now we can do an amortization table. So note the number of periods we have is actually going to be equal to 3 times 12. So we're looking 36 months in terms of the periods. So keeping that in mind, let's build our table out here. And I'm going to say, let's bring this up from 0, 1, and I'm going to bring that down to 36 months by selecting these two, grabbing the autofill. It doesn't matter how long this is. You can do this for 360 months, which would be like a 30-year loan, and that's fine because you could just drag it down like this. That's what Excel's for. That's what Excel's here for. And then we can go to the Home tab, Alignment, and center it. And then we're going to go to the loan balance in the outer column. This is going to be equal to the 11,000 on the balance. And then we'll just do our calculations. Once again, the payment we already calculated, that's going to be equal to this payment amount. And then we're going to take the interest. Now the interest is a little tricky because we got to take into consideration months instead of years, and they gave us the yearly rate over here. Let's do this real quick in the trusty calculator over here just so we can see it. We're going to say we would take the 11,000 times, you could say, the 12, which would be the yearly rate, and that would give you the 1,320 for a year's worth of interest, but then we're only talking about a month here, so I take that divided by 12. That's how I would normally calculate it with a calculator, because that's the way that it's you're not going to get these decimal number, it's the easiest way to do it typically if you're doing that. But when you calculate it in the formula, as we saw, we could do something like this: 0.12, the rate, divided by 12, gives us the monthly rate, which happens to be 0.01 here, which is conveniently, given the problem, of course, we set it up conveniently nicely, so it's 1%. But that can be a little bit confusing. That's the monthly rate, and then we can multiply that times the 11,000. So either way you want to think about it, and it's useful to think about it both ways when you're calculating, depending on whether you're using a calculator or Excel. Okay, so let's do that. We're going to say this is going to be equal to the 11,000. We're going to say times the 12%, and that 12% would give us the result per year. And then I'm going to take that and divide it by 12 to give us the monthly result. And there we have it. So let's then decrease it. So this is the amount we're paying. And by the way, if you didn't divide by 12 and you came up with this, you'd say that doesn't make any sense because the interest is more than what I'm paying. That doesn't make any, I didn't divide it by 12, and then you're going to divide it by 12. So that might happen. And then we got the 365 minus the 110. So we're paying 365 minus 110, which is the rent portion, which we're not getting back. So we're going to reduce the principal by only the 255. So then we got the equals the 11,000 prior balance minus the reduction of the principal. That's going to give us the 10,745. So if we were to record this like in an accounting system, we'd have the loan balance at 11,000. We'd pay, cash goes down 365, but 110 of it is interest and expense, and the loan is only going to be decreased by 255. So once recorded, the new balance would then be 10,745. All right, let's do it a couple more times, and then we'll auto-fill it down. Don't worry, we won't do this the whole way down. We'll just do it a couple more times here. So this is going to be the 365. The interest is going to be equal to the new balance of the 10,745 times the 12%, but that's the yearly rate. So we got to divide that by 12 to get to the monthly amount. That's going to be the 107, it being less than the prior balance. We're going to take the same payment of the 365 minus the decreased interest amount. That gives us an increased loan decrease, which is going to be equal to the prior loan balance minus the decrease in the loan. We're now at the 10,487. Let's do it again. We're going to pay the same amount, which is the 365.36. The interest is now going to be the new loan balance, the 10,487 times the 12%, but that would be the yearly rate, so we divide that by 12, and then we're going to subtract this out. We're paying the 365 minus the 102 interest, gives us the 260. That means the loan balance, which was priorly at 10,487 minus the 260, gives us the new loan balance of the 10,226. Let's do it two more times, and then we'll do it the easy way. 365 payment, interest is going to be the 10,265 times the rate of 12%, but that would be for a year, so we divide it by 12 for the monthly rate. Then we're going to take the amount of the payment, which is still the same 365, but now the interest is going down to the 102, so the decrease in the loan goes up to 263. So now we've got the new loan balance, which was at 10,226 minus the 263, new balance 9963. One more time, and then we'll do it the easy way. One more time, we're going to say this is going to be equal to the 9963 times the 12% up top. We'll take that divided by 12 to get the monthly amount. We're nice down to 100. We got the 365 payment minus the 100 now means the decrease in the principal is at the 266. The prior balance at the 9963 minus the 266 gives us the 9697. Okay, now I'm gonna go back and delete the whole thing so we can do it the easy way. This is painful to delete it, but it's okay. You don't have to delete it. I'll do it. But delete. No! And let's do it again. So this is going to be equal to the 365. Now this time I want to copy it down. That number is outside my table, so I'm going to have to absolutize it because I don't want it to move down. So I'm going to select F4 on the keyboard, $ before the E and the 5. You only need a mixed reference, in other words, $1, but $2 signs is easy to think about, so that's what we'll do. This is going to be equal to the 11,000 on the interest times the 12%. That 12% outside the table again. Don't want it to move down when I copy down. So I'm going to select F4 on the keyboard, $ before the B and 2. Then I'm going to divide by 12, which is a hard-coded number. It will copy down as we go, as we want it to. So we're good to move. This then is equal to the 365 minus the 10. Both of those are inside of our table. Both of them are wanting to be moved down. No absolute references necessary. This is going to be equal to the 11,000 prior balance minus the 255. Again, both those inside of our table. Both of them need to be moved down relative when I copy down, so nothing special needs to happen there as well. Let's go ahead and select these three. We'll copy them down. Now, if I wasn't confident, and I am confident, so I won't do this, but if I wasn't, I'd copy it down just one cell and see if it does what we want it to do. But since we're totally confident, I'm going to copy it all the way down. And the confirmation number here should be that this last one should be 0 if we did it right. 0. Just like I told you. I told you it would. So if I double check these, is it doing what we expect it to? This is pulling that cell all the way up there. Yeah, that's what we wanted. This is pulling that cell all the way up there. Looks good. Looks good. And this end result is 0, making me think that things have been done properly. So you can see the payment's the same. The interest goes down over time. The loan balance then, more of your payment is then a decrease in the loan balance over time. And this becomes quite significant, especially when you're looking at deductible kind of things like a home loan where the interest portion is deductible. And it's important to kind of be able to figure this out, which you can then do because you can then say, okay, for the next year, this is the interest we would be paying, which would be the 1146 and so on. If it was a deductible loan for a business, same kind of thing. It might have tax implications that you have to be taken into consideration. It's also just useful to see what is actually happening in terms of how much you are paying for rent, interest in essence, and how much is being paid back with regards to the loan principal amount. Okay, let's do it again, or one more thing with the tables. Remember, this is a table. This is the backing into the table. You got to kind of do the reverse format to get to the table amount. But I'll set it up in the same format here. We would say this is going to be the payment, which is what we're looking for, times the table. This is what we usually do. It gives us the present value of an annuity. Now, we already know what the end result is. That's the $11,000. We can find the amount from the table and then back into the payment. So the new twist, however, here is that we're not looking for years and yearly rates. We're looking for months, which is going to be 36 months. And that's why we don't often use the tables, or why book problems avoid monthly rates, because 3 years already has you almost to the end of the table, right? The end of the table only goes so far, and I don't even have a table. Hold on a second. Oh, there it is. It's over here, because I see why. Okay, so that it only goes down to 50, and then it starts skipping periods down here, and the rate are even rates, and they don't go below 1%, which is also a problem, which we made conveniently to be 12%, so the monthly rate is simply 1. So it's nice to have nice even rates, in other words, if you're using tables. But in real life, it doesn't really matter, because Excel can take care of uneven rates. So in other words, we're looking for then 36 periods, and we're looking for 1%. So when we go down to the table, note that you've probably gotten used to the periods meaning years and the percents being yearly percents. But what you got to keep in mind is it doesn't matter what the two are as long as they match. So if I'm seeing these periods as months, that's okay as long as I see the interest rates as the monthly interest rate. If I was to look at these in months, looking up 36 months, and then use the yearly rate of 12, that would be a problem. But if I convert these to months using the 36 months, and I use the monthly rate of 1, then I'm okay. So that's going to go down here to the 30.108, 30.108, 30.108. And then we could back into this amount now, because I could say, well, if the yellow number times this is that, then I should be able to say that this is the 11,000 divided by the 30,000.108, giving us that 365.35. Again, we could double check it down here by recalculating that 365.35 times the 30.108 equals the 11,000. Let's bluify that one just to double check it. So there we have it. So we've taken this, we've basically got our payment amount on it. Very useful to then, and this number, note, you can find a lot of tools to help you out to figure out the payment, but using Excel, I think, is the easiest, most transparent thing to do that you can understand it with. Then take that payment, prove it in your mind, and get a better understanding of it by putting it into an amortization table where the end result should be 0, which should give you some confidence that you set up your table correctly, and that'll give you a lot more context on which to make decisions related to car loans, home loans, and that kind of thing.